So good morning everybody and welcome to day one of Big Data Training Program. So I'm Suraj, your instructor for the course, and I'll be taking you through the journey of this 4 months of full-fledged training program. Okay. So before we start this program, let me first tell you the whole idea. What exactly is the roadmap? How are we going to learn, right? So see, I have devised my course curriculum into two parts. I call it data engineering. Okay, the whole course I call it data engineering, which I have divided into two parts, part one and part two. Okay, data engineering one and data engineering two. Think about it as two semesters in your college, right? So in data engineering part one, what I have included is Java. Okay, I have included Hadoop, SDFS and MapReduce, right? SDFS and MapReduce. Okay, and then we have ecosystem components like Hive, Scoop, HBase, 𝗚𝗎𝗴𝗄. Okay, and then we have Java tools which you will basically use in the production every day in your life. So we have some tools like, let's say, Maven, Log4j, okay, JUnits, Git, and so on. Okay, and after that we will also have a project, right? So I have been working in big data since last 8 years right now, and actually I've worked with various companies, small startups, as well as mid-level companies, as well as my last assignment was one of the fan companies. So basically, I have seen that the trend is people prefer using Java and Java based product in the big data development, and that is the reason our course is completely a very detailed program, because it's not possible for me to explain you the big data and make you a champion in just 30 days or 30 hours. So this whole part one itself will cost us almost around 4 months, 4 to 5 months, right? And then we have a data engineering part two, where we would be learning the length and breadth of Scala, Spark, Kafka, Elasticsearch with projects. Okay, the course is so vast that I cannot really merge them together and create a single course. And even if I do so, then it will still cost us almost 8 to 10 months. Right, so this is what we have to understand, because at the end of the day, once you're done with this program, right, you go out to the market to showcase your resume, and you should never feel that, oh, I don't know all these concepts, right? So I call this course as a data engineering course and not a big data course, because if I say big data course, then I may be teaching only the big data components, right? And it does not work that way. When you are going to industry and when you're working in the industry, people expect you that all these tools, because you will be the guy who will be working daily on the system, right? And you would have to push that code to the production, and definitely you'll be using Git for that, and then you will have to work on Maven, Log4j for logging your errors, and JUnit for writing your test cases. So likewise, there are so many other tools which I have not listed it down, but over the period of time, we are going to master this, right? So the course which we are going to start from today onwards is basically our data engineering one, right? Is basically a data engineering one, which will go for next to 4 months. It will be a live session, and it would be a white blackboard sessions, the way we are doing it right now. Okay, and this is the first time I'm launching this live, so that you can have a feel of a classroom training. Okay, all right. So now I want to give you a very important clarity on this Java thing, right? Because many people talk to me over phone, and they call me and they say, hey, I'm from a Python, I know Python a little bit, or I'm an expert in Python, shall I learn this data engineering, right? So see, there are companies who are also using Python, right? There are also companies who are using Python, but I would say, if you go this way, you will be completely ahead of most of the folks. The reason is This whole big data stacks are all product of Apache, right? And all these Apache products are internally written in Java, right? Which means whenever there is a requirement for you to see, whenever there is a requirement for you to understand how are they internally developed, right? What are the code, what is the default code they have written for this and that logic? You have to go to the source code and you will see all the source codes are available in Java. Okay, and I would like to focus on one more point, that see, Python is not a new language. Python is much more older than Java, right? Java was introduced in market in 1995, whereas Python was, introduced in the market in 1990s. So all the developer who built Hive, Scoop, and Space, Uzi, and all, right? For them also they had two options: either to use Python or to use Java. They chose Java because they know nothing can beat the robustness of Java. Okay, so my suggestion would be, when you want to become a big data developer, okay, Java should be your first choice. If you are afraid of Java, then make sure that you spend quality time in Java so that you master it, right? So we have a program of Java of 32 hours to help you get started. It's not it. And I have already given you guys the coursework to this 32 hours of Java, and we are going to, go through the rest of the topics from today onwards. All right. So I hope we are clear, right? So why are we using Java? And in your data engineering 2 course, we have Scala. Scala is another JVM based language, right? So which means if you know Java, Scala would be quite easy. Okay. You may ask me, can I learn Scala only without even having a knowledge of Java? You can. Okay, but you will find certain difficulties, because let's say if you want to work with file input output concept. Now Scala says go back to Java file IO, right? And you open any Java file IO book, you will see all the Java code. So I would not recommend you to directly jump. It has to be a step-by-step process and approach. Okay. So I hope we are all good enough to understand what exactly is this program about, what exactly we're going to cover in data engineering 1 and what we have in data engineering 2, right? So with this understanding, let us move forward and let's continue our discussion. Okay. So I'm just erasing this board, guys. All right. So now we are going to talk about, I would say, data engineering 1. Okay, where the main focus would be on big data Hadoop. Okay, data engineering 1, big data Hadoop. I think it is not visible. Let me write it just below that. Okay. Now, the very first question what we get when we start learning big data Hadoop, right? What is a big data, right? And what is a Hadoop? So, let's say if you want to understand what is a big data, I would say big data is a problem. Big data is a problem to solve the data which is so large that you cannot store it on a single device and you cannot process it within a given time frame, right? So big data is nothing but a problem to solve large data. Okay, now when I say large data, how do you identify if a data is large, right? So you have two parameters. You have two parameters to decide if a data is large or small. The first parameter is size of the data. Okay, and the second parameter is the processing time of the data. Right? Now, how do you say? How do you decide what size of data is large and how do you decide what size of data is small? Right? So, see, when we talk about size, I would say if you have a data which you cannot store on a single machine, easily, okay, then I will call it a big data problem. Okay, the data is big. Now the second parameter, if I have written a program to process one data, and let's say you are not able to process that data within a given time frame, okay, and that time frame is not acceptable by the industry, then I would say the data is big. Okay, let's take an example. Let's take a short example to understand this. Now suppose I have a data of 100 GB. Okay, I have a data of 100 GB. Now first question is, can I store this 100 GB of data in a single machine? Yes. If yes, will you call it a big data? Not really. All right. Next, how much time will it take for you to process this 100 GB of data? Okay, let's say 10 hours. Okay. Now you go back to your company and say, boss, I'm able to process my data, but it is taking around 10 hours, right? And let's say the management says, no, this will not work. We need data, before 10 hours, right? So now I will still call this data as a big data. Okay, so I hope you understood my point. My point is very, very simple. You will call the data as a big data only by looking at these two factors first, right? Now it does not matter what kind of data it is. It's basically the size, and it's basically the processing time. If if you are not able to justify the size and processing time to the management, you will call it a big data, right? The management will say, hey, 100 GB of data and you are taking 10 hours to process. We cannot really accept that. We want this data to be available in just 2 hours, right? Now you say, boss, in that case I have to use multiple approach, like I have to use multiple system to process this data, right? So now see, there are many other options as well. The first option could be you divide this data into, let's say, 50 GB, 50 GB, right, and run them in two different machines, right? You get back some result, merge those result, that you can do, right? But there is no guarantee that your data will always be 100 GB, right? Tomorrow the data will increase over the period of time, right? So the data will increase over the period of time, and that time it will not be possible for you to physically take care of dividing all this data one by one and launching them in multiple machines. That is practically not possible, right? So that time you will face the same problem again, and you will again say, hey, now we cannot really scale it up, because every time I cannot just divide this data into 50 GB chunk and then just process it in a new machine, right? So you have exactly encountered a problem of big data. So what I'm saying is, big data is a problem. Big data is a problem, right? Now, big data is a problem, and what are the solutions? What are the solutions? There are so many solutions available in the market, okay, out of which Hadoop is one, right? Let's understand that with an example. Suppose if I ask you, can you tell me some of the programming languages you know, right? You will say, okay, programming languages, what I know is C, C++, Java, and let's say Scala and Python, right? So these are the programming languages which you know. Okay, now I'll ask you another question. Do you know any database, software system? Then you will say, I know MySQL, right? I know Postgres, I know DB2 from IBM, right? So if you see this programming language, these are basically the physical entity, right? These are basically the physical entity, which means you can see the C++ program, you can see C++, C program, Java program. If I ask you to write a program to check if a number is prime or not, then you will either implement them using one of this language. Is not it? So this is basically what? This is basically your physical entity, right? Something which you will use, right? And what is this programming language? A generic term. I will call it a generic term. This is just a category, right? It's a generic term. It's a category, right? Now similarly, if I ask you, Can you tell me MySQL, PostgreSDB2, what are they in common in general? Your answer would be they are all database systems, right? They are all database softwares. So this is your category again, right? So this is also your category. Similarly, big data is just a category, right? It's a problem. It's basically a category of big data problem. Okay. So big data, when you say there, it like you don't have anything called big data which you will practically like execute, okay, which you'll practically code. So big data is just a category, out of which Hadoop is one such solution, one such implementation of big data. Okay, so Hadoop is one implementation of big data. You have Spark, okay, you have Disco, you have Hydra, and so on. There are a lot of alternatives to Hadoop. Hadoop is just one of them. Okay, but yes, it is very very popular now, and this is basically the winner, the real winner. And of course, Spark is also used quite widely these days. And Spark and Hadoop are basically used together. Okay, they are basically used together. They are really not competitor, they are companion, they are friends to each other. Okay, so this is what we must understand it. Just a minute, guys. Okay, so this is what we have, in terms of big data, right? So big data is basically a problem, and we have so many other alternatives to use this big data. Like we have Hadoop, we have Spark, we have Disco, we have Hydra, and so on. Okay, now let's move on to the next topic. Which company uses big data? After taking this course or after learning this big data, where can I do a job, right? This is very important, because at the end of the day you are learning to take the job, right? You're not just learning to practice it at home. At the end of the day you want to work somewhere, right? So big data is used in every other places, in every company. You talk about big companies, you talk about service-based companies, you talk about mid-level companies, you talk about startups. Every company uses big data. How? Let's understand. Okay, so let me rub this board. So company using big data, right? Now suppose you say, hey, my dream is to get into product based companies, or maybe I'll say like JP Morgan, Citibank, okay, Bank of America, Oracle, right? All this fine. FANG stands for Facebook, Apple, Amazon, Netflix, and Google, right? And other companies, right? They have big data, right? So you will be able to see the big data directly there, because they have a lot of data generated from various different sources and customers. So they definitely have big data. Now you may say, hey, I may not be able to crack into these companies, but I'm okay if I get a job in service-based companies, say TCS, Infosys, right? Wipro, HCL, Capgemini, CTS, Cognizant. Okay, so service-based companies. Now, see, these companies provide services to some big clients, right? These companies provide services to some big clients, and those big clients also have a big data, right? So it does not matter whether you are targeting this or whether you are targeting this. At the end of the day, you are definitely going to work with one of these companies. All right. So that's how big data would be used in every company, right? And if you look into the portal, the job portals, you will find big data is being asked by every company these days. Okay. Now you may say, hey, I have a dream of working with startup, right? Now, when you have a dream of working with startup are basically, see, it is very hard for a startup to survive, right? Unless and until they do not work on the niche technologies, right? So, and the way to work on the niche technology would be pick up something like data science or data engineering and so on, and start, implementing that. So you'll find most of the startups are also, like doing a lot of work on the big data stack. So you will be able to work on various different, scale of companies, right? And the salary range would definitely depends, it depends from company to company, how much salary you can make. I will not be able to tell you the exact figure, because it all depends on the pay scale of the companies, right? But I can give you assurance that you will be, doing better than what you are doing in your non-big data job. That is a guarantee I can give you. Okay, but I will always say hold the equation of 10 into 3. Sorry, 10 into 3 into n. Okay, I always say hold the equation of 3n, which means if your experience is 5, then try to get 15 LPA. I'm talking about Indian salary, right? So try to take at least 3 and into the consideration whenever you feel you want to get into a good company with a good salary, right? But again, it depends on many different factors, right? So that's what we have. So company wise, you really don't have to worry which company pays you good, which company pays you bad. Almost like you'll get a very good salary in all the companies, guys. Okay, now let's move on. So we just had an introduction of the big data, right? So what exactly is a big data? We understood that. Which company uses big data? Every company uses big data. We also understood that, right? Now it's time to understand this Hadoop, right? So how the Hadoop came into market. Okay. Now the very first version when Hadoop started, right, had only two components, guys. Only two components. Number one was your SDFS, and second one was MapReduce. The very first version of Hadoop. Okay, but let's understand before that how this Hadoop came into picture, right? So Hadoop is invented by two scientists, right? 𝗏𝗏𝗘𝗃 and 𝗏𝗏𝗃. These were the two folks who designed this Hadoop framework, right? And how did they do? Let us understand. Like sometime back in 2005 or early 2004, right? These guys were working. These guys were working on a project where they had a requirement of scaling up their system. Okay, they were working on a project which will take a lot of data from internet and does some processing on those data, right? And does some processing on those data. It's not it. No, these folks were constantly receiving a lot of data. These folks were constantly receiving a lot of data, and every time they had a problem of hardware capability, right? So every time they had a problem of this hardware limitations, right? Now, for example, let's say you had 200 GB of disk, and all your 200 GB of disk is full. Is not it? Now, if 200 GB of disk is full, then what you will do, like you will try to upgrade it, right? So maybe you will try to add more hard disk. You'll try to upgrade more on the existing device, right? And suppose similarly, if you had a RAM of 512 MB, you will try to upgrade your RAM to more, right? So constantly upgrading the same machine, right? Constantly upgrading the same machine will have a problem. What? They have a limitation, right? At the end of the day, you cannot really make it so big. Okay. See, I'm talking about 2005, 2006. I'll tell you my story. I purchased my first laptop in 2007. I purchased my first laptop in 2007, and it was the latest configuration in the market. Okay, and the configuration was very simple: 80 GB hard disk. Okay, and 512 MB of RAM. And that time we used to have Windows XP, which used to take only 2.5 GB of hard disk. Okay, and we had dual core at max, right? So this is the configuration which was available in the market for regular users like us, for a programmer like us. Now think about the powerful server. I'm sure they were not even what we have now, right? So if you talk about today's market, 2020, right? My new laptop is coming, and the one which I'm going to bring is 2 TB SSD, okay, and it would be 64 GB of RAM and 8 cores, right? 2020, I have this machine available. Now you cannot even compare both of this. You cannot even compare both of this because if you see the configuration is nowhere even matching, right? So the problem is in 2020 we have a very good hardwares, right? Whereas back in those 2005 the hardwares were all minimal, right? And that time these guys were using some powerful servers, and I'm sure those servers are also not what we have right now, right? So these guys were trying to solve the problem, right? And then every time they were getting huge amount of data, it was a difficult task for them to load their data into memory and run their program. So they kept adding more resources on the same system, trying to make it, they were trying to make it more powerful, right? And this technique is basically called as vertical scaling. This technique is basically called as vertical scaling, which means you are trying to add more and more power to yourself to make yourself more stronger. Okay, so this concept is called as vertical scaling, and this does not work, right? Because see, it's very simple. I cannot get the strength of 10 people no matter what I eat or drink, right? I will not get that power. The power which I can get, if I have 10 people together would be different than the power which I'm trying to obtain myself, right? So because of your hardware limitations, this vertical scaling will not go beyond, like beyond a range, right? There is a threshold for everything. So because of this, these guys were literally frustrated. They were saying, hey, every time we are getting more data and we have to keep some data aside and then we have to start processing and then do something just to manage it. And they were really looking for one or other solution. Now, during the same time, okay, there were people from Google, okay, and during the same time, there were people from Google who published two different papers, and they are GFS and MapReduce, right? So Google published two papers, GFS and MapReduce, and it was just a theoretical paper, right? So when we say paper, that means just a theoretical paper, no implementation of it, right? And this paper was saying, how can you store the data across machines? And how can you process the data stored on all those machines, right? And that is what these guys were exactly looking for, right? So Google published a paper, and they published two different papers, GFS and MapReduce. GFS stands for Google File System, right? And MapReduce has no full form. MapReduce is just a MapReduce. Okay, so Google GFS stands for Google File System and MapReduce is just a MapReduce, right? Now, when they published this paper, these guys were so excited because this is what they were looking for, right? And it says instead of making your system powerful, what you do is try to use multiple systems, right? And your power will increase as you add more systems, right? So this is called as your horizontal scaling. Okay, so this is called as your horizontal scaling, right? Now in Hadoop terms, each of these machines are called as nodes. Each of the machine which has its own CPU, memory, and possibly storage. Okay, so each of these machines are called as node which have their own CPU, memory, and storage, right? So, and if you are putting them together, this becomes your cluster. This becomes your cluster. So that's how your Hadoop came into picture. So this GFS was, GFS was saying how can you use a lot of machines, right, and store the data together by dividing the data into chunks, and MapReduce was basically a technique of how do you write a program which can be distributed on these systems, and they can like execute this whole data together all together, which means they can entirely process all the data which you have already stored in the multiple nodes, right? So this is what the idea given by these guys in their paper GFS and MapReduce. Now, Docketing and team, what they did is they exactly implemented this using Java. Right? Now, see, I'm talking about 2005, right? 2005, these guys are facing the problem, and Hadoop is officially launched in 2006. Okay, 2006, right? So, and I'll tell you, in 2004, I started learning Java, where the version was JDK 1.2, right? When I was in class 11, I felt I should learn some programming because I was from ICC background and we used to have C++ in our curriculum. Okay, so in 2004, I started learning Java, which means Java was there in the market in 2004. I have already personally used that, right? And before that, Python. If I talk about Python, as I told you, Python was released somewhere in late 1990s, right? And my only question here is, why did this guy chose Java to implement this framework, and why not any other language? Python was quite old, right? But why not even language? Why not even Python, right? The reason is Java gives you a very, very good robustness on the programming, right? So if you build a product once, it will run forever. It will run for years. And that is the main reason why people have chosen Java instead of Python. Okay, so you may have a question. You may feel, hey, I love really Python, and Python is quite easy to me, right? And I really feel it's so easy. But my question is, it will be very, very easy for these guys as well, right? Not only you, it will be easy for the whole world. But it's not about easiness, it's about the robustness, right? Because you cannot really compromise building a product, building a framework which will not be so robust, right? I'm not blaming any programming language, but I'm telling you the fact which was present, right? Which was present, and that's the reason many people prefer JVM based products, and that's the reason I strongly recommend people to learn Java, right? And that's what we will be learning in our course. Okay, so guys, I hope we are all clear here. Any doubts? If you have any questions, you can let me know. You can just type on the chat, and then I will be able to see if you have any questions before I move to the next point. Okay, so now we have discussed about the basic introduction to big data Hadoop and how the Hadoop came into the market, right? Let me go and share my screen now, guys. Okay, and let me just go to our course curriculum. Okay, so all the documents, videos, and everything you'll get in my website. I'll share you the link also later. Okay, now let's understand this concepts a little bit more. Okay, so the first thing what we need to understand is the unit of the data, and I feel everybody knows it, but I'll tell you this again. So as you know, the computer stores all the data in form of what? In form of bits, and bits are basically 0 and 1s, right? Whatever you store in the data, whatever data you store in the computer, they're all stored in form of 0 and 1s, and those are called as bits. And bit is basically the smallest unit of data in terms of computer storage, right? Now, as we all know, if you have 8 bits, that makes 1 byte, right? And now 1024 bytes will make 1 kilobyte. Larger than kilobyte, you have megabytes, then you have gigabytes, then you have terabytes, then you have petabytes, then you have exabytes, then you have zettabyte, and then you have yottabytes, and then you have zenotabyte. Okay, beyond that, I don't know, right? So when we come into that era, then we will also see more and more terminologies, right? So this is how the data is basically structured. Okay, this is how the data is basically structured, so that you understand what is 1 GB, what is 1 MB, right? What is 1 TB, what is 1 PB, and so on. Okay. Now you may have a question every time, right? Like, how big are those numbers? When you say 1 MB, how can I correlate with that, right? So let's understand. 1 byte. 1 byte can be one single character, A. Okay, you can store that A in a byte. 1 byte can be a single character. 1 KB. You open a notepad and you start writing some story. What did you do today, the whole day, right? Whatever you write, that can be of 1 KB. Okay. Again, 1 MB can be a small novel. You pick up any good novel and you will see, that would be around 1 MB. For example, you also take some PDF like learning Hadoop or Hadoop in action or Hadoop definitive guide. You'll see them in, MBs only, 4 MBs, 5 MBs, and so on, right? So because they are PDF, so they will consume more. But otherwise, if you keep it on the plain text, then they may be under 1 MB as well. 1 GB, you can consider 1 GB like a small truck, where which is completely filled with papers, and in both sides of the papers something is written. So that could be what you can have 1 GB. Okay, 1 TB, maybe around 50,000 trees converted into paper can give you 1 TB of storage. Okay, 2 petabytes, all US academic research libraries, and 5 EB is all words ever spoken by human being on earth, right? So that means people are speaking a lot of words throughout the world, right? So that's how you can basically classify the data. So if somebody says I have 1 MB of data, so you can think, okay, maybe a PDF kind of size, right? If somebody says I've written a program of 10 KB, possible? Yes, right? 10 KB, 17 KB, 20 KB, you can write a program, right? So when you are working on real project, your code will be very, very lengthy, or you will be writing a lot of code. Okay, so all those things you can say, okay, it will come under your KBs. I have never written 1 MB of code in my entire life, in a single go, right? I might have written it all together, if I like put all my code into a single file, right? But writing 1 MB of code is really impractical in a single project. Okay. Now I've told you the company which uses big data. Every company uses big data. Some examples are AT&T uses big data. Google uses big data to process 24 petabyte of data a day, right? So these are all the informations available in the internet, right? And I've just collected it from them. Similarly, in 2019 we had Avatar movie, right? And it is reported that this movie consumed almost 1 petabyte of storage, right? Because that was all SD quality, like I would say a very high definition videos and all, right? So with all the graphics all together, so it is reported that it had consumed almost 1 petabyte of local storage. Now, some interesting fact, like in Google you'll find almost 20 lakh queries a second, right? In Facebook you'll see almost 34,000 like per minute. Customer is spending almost $300,000 per minute on shopping, and there are almost 100,000 tweets in Twitter. 600 new videos are uploaded per minute. Right? So these are all some use cases which is basically telling us how the data are getting bigger. Right? So think about it. Every minute in Facebook you have 3,400 34,000 likes. Now think about the whole day, right? So the data will definitely become big. Okay, Now, similarly, if you talk about processing capability, it is assumed that, like it is reported that Google processes almost 20 petabytes of data a day. So, what is a petabyte? You go and check here, right? Petabyte is like at least, like 1000 terabytes nearly, right? So 1024, let's say 1000, okay? So it's nearly 1000 terabytes, right? So Google is assumed to process 20 petabytes of data a day. Facebook is assumed to process 2.5 petabyte of user data, like the way you chat, right? The way you upload your videos and send it to your friends, right? So they will be processed in one or other way, right? For various other reasons. Suppose you are chatting with your friend, hey, I'm looking for a personal loan seriously because I have to do this and that, okay? Automatically you'll start getting ads related to related to the loans by various banks, and that is how it comes, right? They process your data to understand what is your requirement, right? So how can we make business out of you, and so on. Okay. Now, similarly, there are some use cases like one popular use cases which you might have heard is, Barack Obama used big data to win the U.S. election. He wanted to understand the, what is how the people are reacting, and how can he, do the campaigning so that he can satisfy most of the users. For example, in India, if I say, hey, we need employment, we need employment, we need employment, right? And then if somebody understands that, okay, people are talking about this trend everywhere, like they want employment, and then let's say the party says, this year we have targeted to give employment to the youth, right? That's how people will campaign it as per the sentiment of the people, right? So that's how, that is one such use cases. Okay. Now, similarly, you have other use cases also. You can just go through them instead of me reading it, because you will get this document at the end of the day. Okay. Now, when you talk about big data, when you see this big data anywhere, people always used to talk about V's, three V's of big data. They are nothing but volume, variety, and velocity. Okay. But over the period of time, many people have come up with their own V's. So over the period of time, many people have come up with their own V's, which means which means now they have also already designed 10 ways. Okay, but I'll not go about talking about those 10 ways. We are okay with the three ways. Volume, that means the data is generating every day, the volume is getting increased, the amount of data is growing day by day. Varieties are like, you will have structured data, you will have unstructured data, you have semi-structured data, and so on. Velocity, the frequency at which the data is getting generated. For example, I may have 1 TB of data to process a day, right? But I may say this 1 TB of data would be generated every 2 hours. Now I will have what? Every 2 hours I'll have 1 TB of data, right? So I will have at least 12 TB of data to be processed within a day, right? So these are basically your three V's of big data. And if you want to practice a lot of big data, then there are so many websites where you can get huge data set. You can get the data set of 300 GB as well. Okay, you can get the data set of 300 GB as well. And these are some of the links which I'll share with you guys, so that you can just go ahead and look into some data, download those data, and work as per your requirement. But we are mainly concerned on Hadoop framework, right? And that is what we have started learning it from today. Is not it? Okay. Now, okay. Now the whole motto of Hadoop is very simple. Hadoop says, don't use a single machine. Always try to use multiple systems, right? So let's go back to the class whiteboard again. Okay. So Hadoop is basically a distributed processing framework. Hadoop is basically a distributed processing framework, and they are implemented in Java. Okay, and it is open source, which means you can always go back, check the source code, right? So it is open source. Okay, so that is open source. Now there is a difference between open source and free. Okay, free means I'll give you the software, you don't have to pay me, you can use it forever, that's okay. But I'll not give you the source code, I'll not tell you how exactly I've written it, right? When you say open source, that means I'll give you the source code so that you can also go and check how exactly it is built, and if needed you can do some modification as per your requirement. Okay, so Hadoop is basically a distributed processing framework which is written in Java, and they are open source, right? And now it is maintained by Apache. Now it is basically maintained by Apache. So all the big data products you will see like Apache Hadoop, Apache Spark, Apache Hive, Apache, HBase and all. So you'll see all those products are basically maintained by this Apache. Is not it? So that's what we have in this big data, right? So big data, the Hadoop says I would be able to process your data by storing the data in different nodes. So as you know, the very initial version of Hadoop had only two things, right? One is your SDFS and the other one is your MapReduce. Is not it? So SDFS is to store the data in a distributed way, and MapReduce is basically to process those data, right? MapReduce is basically to process those data. Is not it? So in your Hadoop, you will have multiple machines. Each machine is called as node, right? And what could be the configuration of this machine? That depends. Okay. For example, I'll give you a configuration which we have used: 32 GB RAM, 2 TB hard disk, 24 cores. Okay, this is one such machine which I have used in one of my work. Okay, the configuration of each system is not it. Now let us try to understand. For example, let's say I have a 100 node cluster. I have a 100 node cluster, which means I have one machine, I have one cluster which has 100 systems, right? System 1, system 2, system 3, system 4, dot dot dot, system number 100. So I'll say dot dot dot, this is system number 100, and we call it node, right? So let me say N1, N2, N3, N4, N100, right? Okay, let's understand what is the total capacity of this cluster. So we have 100, so we have 200 terabyte of storage. Okay, now if I say, hey, 200 terabyte is not really sufficient, I want to have at least 800 terabyte of storage, 800 terabytes, right? Which means into 4, right? So with this configuration you need total 400 cluster, right? But I really don't want to invest a lot of money in buying additional cluster. So what I can do, let me increase this 4 times, right? So 32 GB of RAM, 8 terabyte hard disk, and 24 cores for each node, right? So if I now calculate from this configuration, then I'll exactly have 800 terabyte of storage, right? Now similarly, let's say 32 GB of RAM, 32 GB of RAM, right? So altogether I have 100, so 3200 GB of memory. It's not it. Now similarly you may have a requirement, no, this is not even sufficient for me, I want more, right? I want more. So you can either add your nodes or you can make it powerful. So what I'm trying to tell you here is, in Hadoop you can do horizontal scaling, adding more nodes, or you can also do vertical scaling up to certain extent, right? Because see, you cannot make this system having 1000 TB of hard disk, because 1000 TB of hard disk is not available yet. Is not it? So Up to certain level you can do a vertical scaling, and you can go on and add more and more cluster, making like taking the advantage of this horizontal scaling as well. So vertical scaling is also possible up to certain extent, and horizontal scaling is also possible, as many as you want to add, right? So that's how the data would be added. And let's say 24, so 2400 ports. So this is how the configuration would be calculated. Okay. Now, sometime when you move into, when you get more experience, and when you are working on a company which is directly talking to the customers, right? That time you will have to architect the project, right? So the customer will come with a requirement. They will say, hey, my data is growing at this scale every day or every month. By the end of the month, we have this much of data coming to us. You tell us what is the configuration we really need, so that we can easily process the data as well as store the data for the next 6 months, at least in the Hadoop itself, right? So you have to understand everything altogether, like how much data would be, how much storage would be really required, right? And how much powerful the processing needs to be. Is it okay to have a low memory, the RAM, or do you want to really process using fast processing systems like Spark, right? Because see, everything will come with a cost. Okay, you may say, hey, Spark is doing really great in the market, I'll directly jump into the Spark, right? That is really not a good idea, because Spark will not come as cheap as Hadoop, right? Because at the end of the day, you have to focus more on the memory. Okay, when you are implementing a Spark solution, you'll have to make sure that you have good number, good memory as well, so that you can easily process this data, like quite faster. Of course, Spark can process the data much more faster, even if you are using the same Hadoop cluster. But what I'm trying to tell you is, if you want to take the advantage of Spark, the main focus would be on getting maximum memory, and memory comes with a cost. So do you guys agree with me in the fact that today, let's say 2 TB of hard disk and 8 GB of RAM will cost you, see, around 4-5 thousand rupees Indian currency, right? So this would come at 4 to 5K, right? 2 TB of hard disk or 8 GB of RAM. So you can think about it, like where you can, buy 2 TB of hard disk, you can only buy 8 GB of RAM, right? So when you want to, create a cluster which needs to have a more memory, then of course you will have to spend a lot of money. Okay, now there is a question, let me take it up. If the current configuration is not enough, then we should either scale vertically or horizontally, but no other solution, right? Yes. So see, either it will be vertical or it will be horizontal. It will not be diagonal, right? So either this way or this way, right? But at the end of the day, you are able to scale it up, and that is what we are looking for, is not it? Okay, so that's what we had, like in part of Hadoop, right? So that is what we wanted to start with today. So I hope you understood the concept of what is a big data and what is a Hadoop. How are they different? They are really not different, but one is a category and another one is basically a solution. And I hope you understood how the big data is used in the industry, which company uses big data. As I have told you, every big company, every service-based company, because ultimately they work for a big client, right? And then we started our discussion on Hadoop, what exactly Hadoop is, and how they are basically, how they came into the market, right? What were the challenges faced by the inventors, 𝗀𝗏𝗏 and 𝗏𝐾𝐿𝐴, and at the same time, your Google published 2 papers, and then they started implementing, and they started writing the program. They started implementing the solution using Java, and that's how the initial version of Hadoop came into the market, right? So this is what we have discussed so far today. Okay, now let me tell you how exactly this course is just going, how this course will move forward, right? Because we all are here to learn this big data in detail. Okay, now let me close this up. All right, so our data engineering part one would start in this way. I've already given you a Java 32 hours of course, right? Which you will finish at your own speed, but try to finish it as much as possible, because by the time we start a solid map reducing, right, a solid map reduce concept, you need to be well versed with this Java. Okay, now within this Java itself, I have given you a lot of assignment to solve, and all these assignments are basically one or other assignment which I faced in my work. Small assignments, but they are very important, because I will assume here that the audience have no clue about the Java programming, right? So if you feel you're good enough in Java, feel free to skip it at your own risk, right? If you feel that I have 10 years of experience in Java, then I don't think you will, definitely you really don't need to solve these problems, right? But if you are new to Java, I would suggest you to finish this Java 32 hours as soon as you can, and complete all the assignments whatever I have given. Okay. Now by the end of the course, which means by the end of the 4 months, okay, by the end of the 4 months, you should be solving a lot of problems. One is, let's say, from codingbad.com. Okay. We should also pick up some projects from project Euler. Okay. And then first my assignment, no, first coding bad. Okay, this would be the priority. I'll show you how. Then my assignment, because these are quite easy. Okay, and then the project Euler. Okay, then over the period of time, you have to be capable enough to solve problems from HackerRank, HackerEarth. Okay, and lead code, and so on. Okay, now let me tell you one very important thing which you should not confuse, right? So see, any company will pay you for your problem solving skills. This is the very important thing, because I'll tell you, there are tons of training centers teaching big data, there are tons of people learning big data, but when it comes to the real job, there are plenty of opportunities, and I'll be very honest with you guys that we are still not able to fill that position. Why? Because everybody feels that big data is just 30 hours of course, right? They finish the 30 hours of course, and then they go to the interview, and it is just like going to the battle without carrying a weapon. And what will happen? You will be defeated every time. We have got a lot of people, and I'm sure a couple of you who are attending this course, right? I'm sure many of you are new to it, but I'm sure many of you have also taken a training from somewhere else, right? So see, the whole idea is 30 hours is not sufficient. You have to know it, you will know it either today or maybe during the interviews, right? So that's the reason the whole agenda would be to help you, like, improve your logical skills, because this is what going to pay you salary tomorrow. Not just the big data. Big data anybody can learn in a day or in 2 days, but over the period of time, how do you project yourself, as a problem solvers, right? Because in front of you, what you will have is a large data set. You have to write a program. Your program should run on various clusters, right? And that should process huge amount of data, right? The logic would not be so easy, right? Many people are like, okay, I will just learn Hive because I know SQL, right? And let me get into the market. It is possible, but very few company will hire you only based on Hive, because no company wants to, fire an employee by just hiring them with only one skill, and later fire them because you are not fitting the the project requirement. So when company hires, company wants a superman, right? And it takes some time to become that superman, and that is what we are going to do. Okay, so see, as we are moving with the course, right, everything will have a deadline, and all of us have to meet the deadline. Okay, because if you don't meet the deadline, then 4 months will be over and you will not be able to cover all of them, right? I will be guiding you this through this, but you will have to solve it. I'm not going to solve it for you, right? Because it is your battle. I can just guide you. You have to go and fight your own game. Is not it? So that's what we will have, right? So once our Java is over, we will start with coding bad, project Euler, HackerRank, HackerEarth, lead code, and other things, so that over the period of time your logical thinking, your problem solving skills are also increased. Okay, so that is the one thing which we will focus. Okay, and then as we move on, we will start with MapReduce. Okay, we will learn the very basic MapReduce initially. Okay, because I believe you are still learning Java, right? So we'll learn with the very basic MapReduce, and then we will start finishing all the ecosystem components, whatever we are supposed to cover, Hive, Scoop, and all, right? Now the good point is we have collected almost interview questions on all these topics from 150 plus companies. Okay, and I'll show you that in my website. At least I have access to it, so let me just share my screen and show you, because this will help you to understand what exactly, at what level exactly we are trying to prepare ourselves, right? So let me just open my website, onlinelearningcenter.in. Okay, and interview questions. Okay, now if you see, we have almost 157 companies interview questions only on big data. Okay, and topic wise, there are 38 different topics on which the interview questions are contributed, and they are all contributed by interview going candidates like you, right, who went to interview, they faced the questions, right, and then they came back here and they contributed. Is not it? And that is how this is growing. Is not it? Now these are the real interview questions faced by the people in the industry, right? Because I don't have time to give you 150 to bring 157 companies interview questions all of a sudden at the middle of the night. Okay, let me go to topic wise. So if you see, Hadoop 190 plus, Scoop 160 plus. Of course, there would be repetition because the same question may be asked in 2-3 different interview questions, right? Data structures, Java, right? If you say Java is not even asked, look into it here, right? MapReduce, right? HBase, 𝗚଼cie, and so on. So when I'm going through the course, when I'm going to teach you this course, I'll make sure that I do all the homework of going to all this, questions on various ecosystem component, and I'll make sure that everything is taught to you guys, so that when you go to the interview, you should not feel that, oh, this is a new concept which is being asked. And that's the whole agenda of bringing this interview questions together, so that like you will be able to prepare a much more better, right? So that's how the interview questions would be really helpful to each of us, right? All right, so that is what we have. And of course we conduct also the hackathon, which would be basically a monthly event, okay, for our premium members now, wherein I'll give you a typical problem to solve, and you will have to solve this problem at a given time frame. You clear the hackathon, you get a points, right? You will be awarded a points, and the more point you will have, I can help you getting placed, because sometimes I get call from the company saying that, Suraj, we are looking for good candidate. Why company comes to me? Small companies. Okay, I will not say that Amazon comes to me for the recruitment. That would be not a fact. Okay, small companies comes to me who are ready to pay you good salary, and they come to me because they know that how difficult it is to get people from the market. So they believe at least trained people from OLC would be quite better than the rest of the market, right? So that's what we would be focusing. We would be focusing on the premium hackathon for you guys, where you'll be solving the problems in a given time frame of 3 hours, 2 to 3 hours, and that will make you more better. Okay, so we have a couple of public hackathons here. Please go ahead and try to solve some of the problem, and I'm sure you'll find it little challenging, right? So you can just go back and solve the problems. 3 problems we have added here. We will add one more, and so on. But then we will have a premium hackathon every month. Okay, that's what we have. And then we will get started with the course. Exam terms. Now there's also one important thing where we have added SCJP level of questions. Okay, these are SCJP level of questions which I will ask you guys to solve, so that over the period of time you become better in Java. Okay, this is basically just 40 questions out of around 800 samples what we have. Every time you try, you get a new question. Every time you try, you get a new questions, right? So that's going to help you, to improve your Java skills as well. Hadoop questions, they are also again from CCD 410 terms, but this would be equally very good to help you understand how good you are learning the subject. Okay, and that's how we will also bring CCA 175 certification and all, but certification is not our priority anytime. The reason is there are so many certification, Cloudera, then MapR, then Databricks, these, that, and whatnot, right? And I really don't want to concentrate on just the certification. We will concentrate on the knowledge, we will concentrate on the concept, and that is what people are missing these days. Okay. All right, guys. So now it's a time for me to take up any questions, whatever you have.